Welcome back, ninth grade. I'm doing the second half of 7.4 so that you didn't have a million years of chemistry lecture yesterday. So I'm pretty awesome. We're studying empirical formulas today, and the idea is as simple as it can be. It's the lowest ratio of whole numbers that you can find in a molecule. So if you are given a molecule like CH4, okay, that's methane gas. Well, C is 1 and 4 is 4, or H is 4. There isn't a number that goes into 1 and 4. Okay, so it's as simple as it can be. So this is the molecular formula because it is the formula of the molecule. A methane molecule has 1 carbon and 4 hydrogens in it. It's also the empirical formula because it's the lowest ratio that you can get. So sometimes the molecular and the empirical are the same. Others you can reduce. So if you can reduce them, and then whatever is reduced is your empirical formula. So for instance, if you see this one, C5H10O5, all of them are divisible by 5. So divide 5 into each one of those numbers and you get C, 2 H's, and O. And so your empirical formula is CH2O. How about that for easy? The molecular formula is the same, or it's a multiple of the empirical. Okay, so everything is multiplied by 2, or everything's multiplied by 3. So they're either the same if they're like CH4 was the same, or you multiply everything by 2, and then the molecular formula is double the empirical, or 3 is triple the empirical, or etc. Okay, so for instance, empirical CH, well, acetylene is C2H2. Benzene is C6H6. So going from the molecular to the empirical is easy. I just look and say, they both have 2's, divide them by 2, and you end up with CH. Or C6H6, they all have 6's, divide by 6, you end up with CH. Do you see it's harder to go left to the right, or right to left? Because I'm not sure how many to multiply by. Okay, so we'll look at that in a minute. What's the empirical formula of C4H8? Well, 4 goes into 4 once, 4 goes into 8 twice. So ta-da! What's the empirical formula of C8H14? Well, 2 is as good as I can get, so that has to be 4 and 7, and so that one was it. How about CH2O? None. It's the same. So, I'm sorry, they're going backwards. What's the possible molecular formula? So it can't be this one because they're the same and this one's not. This one is double C, double O, and double 2. I'd say it's this one. A compound has an empirical formula, SN. If there are 4 atoms of nitrogen in one molecule, what's the molecular formula? Okay. Well, I know that it's a 1-to-1 relationship. SN is 1-to-1. If I have 4 nitrogen, I also have to have 4 sulfur, and so it has to be number 3. A compound contains 7.31 grams of nickel, 20 grams of bromine. Calculate its empirical formula. Okay, now if I've got 7.31 grams of nickel and 20 grams of bromine, I want, these are weights, I want numbers, because eventually I'm going to get a formula saying 1 molecule or 1 atom of this to 3 atoms of that, or 6 atoms of this to 4 atoms of that. Okay, so in order to get a weight into a number, I'm going to go from grams to moles, and that's the molecular mass. So we've done molecular masses in the past. 7.31 grams of nickel. I'm going to get my periodic table out, and nickel is 58.69. Okay, there's 58.69 grams in a mole. I do the same thing with bromine. 20 grams of bromine. I look at bromine, it's 79.904. Okay, now I can take grams and divide by grams and end up with moles. I've converted grams into moles. So we have 7.31 divided by 58.69, and I have 0.12455 moles. Okay, let's do it again with bromine. 20 divided by 79.904 gives me 0.2503 moles of bromine. Now I want a ratio. So I want 1 to 2. So I want one of these numbers to be a 1 and then see if the other one can be a 2, or 1 and see if the other one can be a 3. So I'm going to take the smaller of these two numbers and divide them both into each other. Not into each other, but the smaller number divided into each of these. So the smaller number is the nickel. So if I divide 0.12455 into that, I get the number 1. If I divide it into this, 0.12455, divided by 0.12455, I get a 2. Okay, that's pretty cool. It was 2.00. That means nickel is going to be 1 and bromine is going to be 2, and the empirical formula will be NiBr2. Now this has to be looked at. What you do is go from grams to moles. Once you're in moles, the smaller number of moles divide into each. And then you end up with whole numbers. And then those whole numbers are your subscripts. You don't have to do a 1, but the subscripts at the bottom of your formula. What if when you divide, you don't get a 1, you don't get a 2, you don't get a 6, you get a decimal, okay? So for instance, what if you get a something 0.2? Well, if you get a something 0.2, and so you end up with 1.2 on this side and 2 down here. Well, if I multiply 1.2 by 5, then that 20 cents times 5 becomes $1. 1.2 times 5 equals 6. And then I multiply 2 times 5 and I get 10, and now I've got whole numbers. Okay, so here are the decimals, and you can look at this table. If you've got quarters, I'm going to multiply 4. You're trying to get $1, right? Got 20 cents. How many times do you have to multiply 20 cents to get $1? 5. Multiply all the numbers by 5. If it's 0.25, that's a quarter, you need to multiply by 4. If it's 0.33, multiply by 3. If it's 0.5, you multiply by 5. Okay. If it's 0.67, which is 2/3, 0.67 times 3 will give you a 2. Okay, and then you would multiply the other one by 2 as well. Percent composition using 100 grams. Okay, let me go ahead and do a problem with you, and we'll come back to this. Aspirin is 60% carbon, 4.5% hydrogen, 35.5% oxygen. What is its empirical formula? Okay, typical chemistry question, but one of the hardest. This is one of the hardest questions of the year. See what we can do. Since it says percent, I'm just going to use 100 grams. Okay, a percentage means parts of 100. So instead of using another amount that I could pick, like any amount, I'm going to make it easy and say 100, and at 60% is carbon, okay, then that means 60% of 100 is 60 grams would be carbon. 4.5% is 4.5 grams of hydrogen, and 35.5% is 35.5 grams of oxygen. So when you're given percentages, choose out of a 100 grams. Then 60% of 100 is just 60. And this number simply becomes that. I don't have to do any math at all. Now I'm where we started a minute ago, where you're given grams. Now I go through the periodic table and find moles. Once I find moles, I can get a ratio. So I look at the periodic table. Carbon is 12.01 grams per mole. Hydrogen is 1.00794 per mole. That's grams. Oxygen is 15.9994 grams per mole. I just looked at the periodic table. Those were where I found the numbers. Okay, so I'm going to take 60 divided by 12.01, and I get 4.995. Let's do it again. 4.5 divided by 1.00794 is 4.46. I'm going to just go ahead. I can do it this way. 4.46. Last one, 35.5 divided by 15.9994 is 2.218. All right, now I've got moles. That's numbers. So you can kind of see that this is 1 and this is 2, kind of. Let's see what we can do. I'm going to take the smallest number and divide it into each. Okay, so the smallest number is the 2.218. So I'm going to take 4.995 divided by 2.218, and I have 2.25. I'm going to do the same thing with a 4. 4.46 divided by 2.218, and I have that as a straight 2.0. And then the rest is into itself will always be 1. Well, I don't like the first one. 2.25 is not a whole number, and I need whole numbers to do a ratio. Our formulas are always whole numbers. But I see the quarter. There's 4 quarters in a dollar, so if I multiply each one of these numbers by 4, I'll get a whole number. Okay? So 2.25 times 4 is 9. 2 times 4 is 8. 1 times 4 is 4. Now I've got nice, beautiful whole numbers, and your answer for aspirin is C9H8O4. And this is the empirical formula for aspirin. It may be that it's a double or a triple or quadruple when it's a molecule. I think that's actually right. C9, I think, is aspirin. Okay, so very hard problem, and you may have to do this several times to get a hang of it. But you can email me and I'll try to help you.